Hey guys, I'm Tess.
And I'm Vera. Today we're going to be talking about the rules of exponents for Algebra 1.
We're going to be showing you some problems on a whiteboard and then we're going to talk through them.
We recommend that you take notes along with the video as we complete the problems so that you can remember them better when you do them yourself. We'd like to start by explaining some of the lingo that we'll use in this video. So you'll often see this setup. And in this case, x is considered the base and y is considered the exponent. X and y can be substituted for any number. So in the case of 9 to the power of 5, 9 is the base and 5 is the exponent. There are a couple of things you need to keep in mind to go along with this. First of all, when you have just x, or any number without an exponent over it, it just means that it's taken to the first power. Because that means it's not taken times itself any number of times. Another thing you'll just have to memorize is that x to the 0 equals 1, no matter what number x is. So whether it's 3 to the 0 or 300 to the 0, the answer is still 1. So let's get started. Our first strategy is that in order to multiply terms with the same bases, in this example, the base is x, you would add their exponents together. So you have these two terms multiplied together, and what you need to do is combine their bases. And you do that by adding their exponents together. So you can see how this rule works. Now I'm going to show you an example of why it works using real numbers. Say you have 3 squared times 3 cubed. We're going to evaluate each side separately. So 3 squared equals 3 times 3. And 3 times 3 equals 9. So 3 squared equals 9. 3 cubed equals 3 times 3 times 3, which equals 27. Now, in order to follow what the problem tells us to do, we'll need to multiply 9 times 27. And the answer we get to that is 243. Now let's keep this answer in mind as we solve this problem using our rules for multiplying terms with the same bases. Using our new rule, we know that we need to add these exponents because the terms have the same bases, 3. So we add the exponents and take 3 to the power of the added exponents. So if we add these together, we get 3 to the 5th. And if you put 3 to the 5th into your calculator, you'll find that it equals 243. So this rule really does work. Now if you have a problem like this, where there are numbers in front of the terms, you multiply the numbers together just like you would in a normal multiplication problem. So you would have 4 times 5, and then you would have that times x to the y plus z, using the rule where you add the exponents. So your final answer would be 20x to the y plus z. Here's an example for you to try. Pause the video and give the problem a shot yourself, then continue playing it to see how I find the solution. What you would do for this problem is you would multiply 3 times 2, as we did with the numbers in the previous example problem. Then, because these two terms have the same base, x, you would take x and add the two exponents together. Alright, so you have the basic algebra done, and now you just have to simplify this problem. So 3 times 2 is 6. And then 5 plus 8 is 13. So your final answer would be 6x to the 13th. Our next rule is that in order to divide terms with the same base, you need to take the numerator's exponent, which is the exponent of the top term, minus the denominator's exponent. For this, you can think of the fraction bar as a minus sign. And let's try another problem. Just like when you multiply terms together, you also divide numbers in the numerator by numbers in the denominator, just like you would regular numbers. You also have to keep in mind that when x doesn't have an exponent next to it, it just means that it's x to the first. So let's get started. We're going to divide the two numbers, so 6 divided by 3, and then we're going to take the base of x and subtract the numerator's exponent from the denominator's exponent. Now all we have to do is simplify. 6 divided by 3 is 2, and we can put the x, and 5 minus 1 is 4. So your final answer is 2x to the fourth. Here's a problem for you to try on your own. Pause the video for a couple minutes and try it, and then I'll show you the solution. Just like with our other problems, we're going to divide the numbers just like we would in a normal division problem, 24 divided by 8. Then we're going to take the base of y and take the numerator's exponent, which is 7, minus the denominator's exponent, which is 3. Then we simplify. So 24 divided by 8 is 3. And we put the y, and 7 minus 3 is 4. So our final answer is 3y to the fourth. You can solve problems that use more than one variable in the same way. So in this case, there are terms that have x and terms that have y. You combine the x terms' exponents, and then you combine the y terms' exponents. You don't mix the two. I'll show you what I mean. So just like with the other problems, we divide the numbers as you would in a normal division problem. In this case, it's just going to end up staying 3 over 2 because that can't be simplified. Now let's combine the x terms, keeping in mind that when x doesn't have an exponent next to it, it just means that it's x to the 1. So you would have x to the 2 minus 1. Now to combine the y terms, we have y to the 6 minus 4. Let's combine this. So 3 over 2 stays the same. Then you have x to the 2 minus 1 is just 1, but you don't need to write 1 because that's implied. You don't have to put the exponent 1 above the x. And then you have y to the 6 minus 4, which is y to the 2. And this is your final answer.
So now we're going to be working with parentheses. The thing with parentheses and exponents is that to work with the parentheses, you have to multiply the exponent on the outside of the parentheses with the exponents of all of the terms within the parentheses when they are multiplied or divided. If the terms inside of the parentheses are addition or subtraction, do not distribute the exponent on the outside. Here, you distribute the 4 to the top and the bottom, and then multiply the 4 by the 2 to get 8. Here, only distribute the 2 to the x squared and the parentheses. Now, the 2 needs to be distributed to each term because it's multiplication. You need to distribute the 5 by multiplying it. First, use the division rule to simplify, then multiply it. You can either distribute first, then simplify, or simplify first, then distribute. With negative exponents, x to the negative y is the same as saying 1 over x to the y. Either the division rule can be used or the negative rule. Both the multiplication rule and the negative rule work to solve this problem. Simplify, then use the division rule, then the negative rule. First use the negative rule, then the division rule, then simplify. Thank you. Bye.